For decades, geology had a reigning king. Mauna Loa, located on the island of Hawaii, was the historical, undisputed benchmark for Earth's active shield volcanoes. Its visible footprint is staggering. The volcano makes up 51% of the entire island and rises roughly 30,000 feet from the ocean floor. This diagram shows a cross-section of the island's geography. The volcano's mass is so immense that it physically depresses the oceanic crust beneath it by an additional 8 kilometers. When you measure that total vertical height from its depressed base all the way to the summit, Mauna Loa reaches 56,000 feet, absolutely dwarfing Mount Everest. For a long time, this highly visible behemoth defined the absolute physical limit for how large a planetary volcano could grow. That consensus shattered in 2013 with the discovery of a massive feature named Tamu Massif, hidden entirely underwater in the northwest Pacific Ocean. This map diagram shows the geographic footprint of Tamu Massif. It covers 120,000 square miles, taking up the same amount of space as the state of New Mexico. This discovery temporarily stole the crown from Mauna Loa. In sheer area, Tamu Massif even rivaled Olympus Mons on Mars. This proved that the most colossal geological structures on Earth hide out of sight in the abyssal depths, rather than towering into the sky. The discovery triggered intense scientific scrutiny. Expeditions sent offshore research vessels to the site to gather data and extract core samples from the deep ocean floor. The resulting magnetic data revealed a fatal flaw in Tamu's classification. It was not a single centralized shield volcano. This diagram shows magnetic readings from the rock. Data identified crustal blocks with opposite magnetic polarities, arranged in linear patterns. These stripes are the definitive signature of seafloor spreading at a tectonic ridge. The rock formed as plates pulled apart, not from a single eruption. Because Tamu Massif is actually an oceanic plateau formed by a ridge, it was disqualified. The title of the world's largest single volcano was vacant once again. The search shifted 700 miles northwest of the Big Island to the Gardner Pinnacles, 2 barren rocks rising a mere 170 feet above sea level. Geologists used bathymetric and marine gravity mapping to scan the area. These techniques measure the physical depth and density of the ocean floor to see past the waterline and map the solid rock beneath. Beneath those tiny pinnacles, they found Puhahonu. It is a single, massive shield volcano containing 148,000 cubic kilometers of rock. This chart shows how that volume stack up. Mauna Loa sits at roughly 74,000 cubic kilometers. Puhahonu is exactly twice its size. The actual largest shield volcano on Earth was hiding in plain sight, completely disguised by the waterline. This raised a central thermodynamic question. What mechanism allowed this specific volcano to produce such a massive volume of magma 14 million years ago? Geologists dismissed the standard hypotheses. The Earth's crust wasn't unusually thin in this region, and the tectonic plate wasn't moving slowly enough to pool that much molten rock in one place. This chart shows the specific chemical concentration found in Puhahonu's rock. It features a high concentration of phenocrysts, early forming crystals in the magma, which indicate a massive 24% partial melting threshold. That marks the highest melting temperature recorded for any Cenozoic basalt. This extreme heat points to a singular cause, a solitary wave. A solitary wave is an intense, localized thermal pulse. It travels upward through the deep Hawaiian mantle plume, delivering a massive, concentrated surge of heat to the surface. Puhahonu's gargantuan size is the direct physical record of the hottest known thermal event in recent Earth history. The discovery of this solitary wave updates our working model of the Hawaiian hotspot and mantle plumes in general. Instead of operating like a steady, predictable geological conveyor belt, the Earth's thermal engine is capable of sudden, violent surges of overdrive. Tracking these ancient thermal anomalies helps scientists map the unpredictable thermodynamic pulse of the deep Earth today. Volcanoes function as crucial temperature gauges for the chaotic thermal engine operating thousands of miles beneath our feet. Today, the violent, massive origins of Puhahonu stand in stark contrast to its quiet state as the tiny Gardner Pinnacles. There is a drastic disparity between the gargantuan subterranean reality and the mundane surface we actually see. Earth's most colossal geological wonders, mountains that dwarf Everest and outsize entire nations, are almost entirely invisible to the naked eye. Understanding our planet requires looking past the visible horizon and measuring the invisible forces that truly shape the globe.